Don't be jealous. Some people just have the creative knack. Mr. C7. Joey, is that future you?
Yeah.
Good. So this is page 115. We're working on number one. If someone's got their mic on, or is it me? No, it's not me. Someone else. Guys, someone's got their mic on. Okay. Number 1A. Shoot. One of the problems here already. What's going on here? My screen's acting wonky. Okay. We have to be able to predict products, which means you first of all recognize what type of reaction it is. This is a combustion. How do I know? It's a hydrocarbon. A hydrocarbon plus an oxygen. Hydrocarbon plus an oxygen. That's your clue. Now, what's a hydrocarbon? Something that's simply made up of carbon and hydrogen. Okay, it could also be an alcohol. And what's alcohol? It's basically a hydrocarbon with one oxygen tacked onto it. Okay, the products will always be, this is how you can predict it very easily for combustion. The products are always the same, carbon dioxide plus water. And you kind of somewhat know this from experience about the water. I mentioned this to you before. Gasoline is a hydrocarbon. You're burning with oxygen in the air. That's why we have an air filter system in the car. We want clean air passing through so we can extract the oxygen and it can burn the gasoline. And on the and at the back end of the tailpipe, you get, in some cases, when you look at it on a cold day, steam coming off the exhaust, right? That's water. That's your H2O. There's carbon dioxide coming as well, but that's an invisible gas. Okay, so that's how you predict it for combustion. Automatically, products are carbon dioxide and water. Let's balance it. Use my red pen. 2 carbon. Start with the carbon. Okay, 2 carbon, that's balanced. Next, hydrogen. There's 2 hydrogen on both sides. That's already balanced. Or and 1 oxygen on the right. 1 there. 2 here. Well, wait. There's 3 here. 3 oxygen here. 2 on the right. That looks like a 20. 2 oxygen on, pardon me, the left. Okay. How do I make Mr. C7? Try this out. Okay, that'll give me 3, but that's mathematically correct. But what do I Let me see here. Give me a second here. I made a mistake here. This is 2 times 2. This is actually 4 plus 5. So I need to put a 5 here. Need to put a 5 here. Okay. Now that's mathematically correct. So how do I make it so? What do I need to do in order to make it chemically correct? Can't have fractions. Yeah, multiply everything by 2. So you end up getting 2C2H2. 2 times 5 over 2 is 5. Times O2. 2 times 2 is 4. Plus 2H2O. Okay. Okay, next one, Cl2 plus Ki. What do we have here? We have an element plus a compound. That's your clue. That's your pattern. But yeah, it probably is single replacement. So it's single replacement. What will happen? If this were a metal, it would replace the metal. That's the trick. Okay. So this produces, doesn't matter the order, I'll put the K first. KCl. It kicks out the iodine, you get I2. Not I, but I2 because I is diatomic. Okay, it's not balanced. Sometimes I'm finding doing it the quick way. It's easy to make mistakes, so I'm doing it the quick way to save us time. I would recommend still taking your time with it. You can see when I rush it, sometimes I overlooking stuff. So take your time with it. But I'll do it quickly again, just so I can save time for you, because the main emphasis is predicting the products here. So I need 2Cl, put a 2 there, put a 2 there, and that works out. C, Al plus O2. So look at the pattern. Element plus element. That should remind you of something. Yeah, element plus element is a pattern for synthesis, coming together to form. Yeah, I'll put this in white here. So aluminum, we're going to make sure that we've got the right formula. Aluminum oxide. I got that by crisscrossing in my head. You should be able to do that by now. Okay, so this is synthesis. Synthesis. It's not balanced as it is, but we can do it. There's a 3 here. There's a 2. Okay, if you look at it, it starts off with AgNO3. Okay, so this is a compound plus a compound. That's a pattern. Should remind you something. What's it a pattern of? What might it be? Good, double replacement. The way you could tell for sure is that and it's giving me a hard time. This, it's a metal and that's a metal. They can replace each other. So they'll trade places. Double replacement. Okay, they're going to trade places. So the lithium will go with the nitrate, and the silver will go with the chromate. So start with the silver first. So you get Ag. I'll complete the crisscross in a second. So the CrO4 is -2, so it should be Ag2, I believe, right? Yeah. Good. I'm going to move this over. I don't have enough room. Plus, again, the lithium is going to trade places with the silver to give lithium nitrate. Okay, it's not balanced. We can balance it quickly. Try this out. Does that work? Looks like it. Okay, I'm doing it again. I'm doing it quickly. I would set up a table. Take your time with it as far as balancing. E, you've got a single element, H, not element, compound. What could it do? What's wrong with it? Yeah, it's good. Atomic. Put a 2 here, put a 2 there, and you just said it's decomposition. Okay? F. HNO3. HNO3 plus barium hydroxide. Okay, that's your pattern. Acid, it's an acid plus a base. I know that it's an acid because of the H and a base because of the OH. What type of reaction is it? Good. Neutralization, you could call it acid base too. Neutralization. We tend to use the word neutralization because water is always produced. I'm going to write it as H, one H, and one OH. Water is neutral. What's left over is called a salt, made up of the positive ion and the negative ion. So barium nitrate. Okay, it's not balanced yet. Quickest way to balance it is to count up the number of hydrogen and hydroxide. Okay, got 2 hydroxide here. Let's try making the right side 2 hydroxide. That means with the 2 in front, there's now 2 hydrogen and 2 OHs. Check, check. Balances the hydroxide. I need to now go back to the left and double the number of hydrogen. That should work out. That should work out. G Zn plus H2SO4. Here's a clue before we even begin. Hydrogen can act as a metal. In this case, it's acting like a metal. Or a non-metal in some cases. Okay, if it's on the left side, well, anyway, I won't go into detail. It acts like a metal in this case. This is a metal. Okay, and the pattern is element plus compound. What's that a reminder of? Yeah, this single replacement, where in this case, the Zn replaces the H. Because the H acts like a metal. So you get Zn, I think Zn is +2, right? Yeah, it is. Good. Plus, kicks out the H. What's wrong with that? What's 2? That? Yeah, hydrogen is diatomic as well. Okay, it's already balanced, and you were right. It is single replacement. Okay, H. Okay, element plus element. What do you think happens to them? Yeah, they come together to form calcium oxide. Yeah, it is synthesis. Element plus element. That's your pattern. Synthesis. Balanced. No, there's 2 here. Double that. Should be okay. Okay. I'm gonna need a little more room here. Put the I over here. Sodium hydroxide. Plus, here's a tricky one. This is an acid. The H instead of at the beginning is at the end. That's one of the exceptions, okay? It's because of the structure of it. It actually looks like this. This is very rough, but if you were to look at it, it's called acetic acid. So you got C here, or H, CH3, CH3, C, O. I don't know how this would bond. I'd have to think about it. It looks something like this. CH3COO. And then there's an H. Now there's another bond in here somewhere. I'd have to think about it, but that's roughly it. Okay, and that's not even correct because it's one bond there. So I have to think about how the bonds look. But that's the general shape. It looks like that. It actually looks like that physically. It's a string. So that's why they tack on the H at the end, because physically the H is at the end. Okay, so this is an acid-base reaction or neutralization. Okay, if I can make mistakes, you can make mistakes. Don't worry about it. Some guy gave me a hard time the other day. I was operating on 3 days without sleep. What else does it produce? Neutralization produces water. I'm going to write it as HOH. It's helpful. You don't have to. It's helpful. What's the other product? What's it made up of? Made up of the positive ion, and then this is actually the negative ion here. It's usually written last. It's written first here. So, anyways, here's the turnaround. When we're writing sodium acetate, we put the metal first, unlike the hydrogen. Don't ask me why. It's just the way they do it. Doesn't make sense because physically the Na would be at the end as well, but whatever. Is it balanced as is? Yes? Yes. Good. Jay, they've tricked you here. Oxygen plus C15H30. Usually we write the hydrocarbon first. Combustion, yeah. It's still, it doesn't matter. The order doesn't matter. It's like 1 plus 2 is 2 plus 1. What's always a product of combustion? Mm-hmm. Yeah, you got it. CO2. You both said it. CO2 plus H2O. Good. I'll make an attempt to quickly balance it. 15 carbon. 15 carbon. Hydrogen, there's 15 carbon here. There's 30 hydrogen here. Try this. 15 times 2 is 30 hydrogen. How many oxygen do we have now? 15 times 2 is 30 here. 15 times 1 is 15. Yeah, total of 45. Back over here. How do you make it so there's 45? 22 and a half? Well, you can't have half, so what do you have to do? Yeah, that's, wow, that's weird. 45O2 plus 2 C15H30 produces 30 CO2 plus 30 H2O. It's a 30, not a 3. Okay. Last one, K. RB2SO4. RB2SO4 plus KF. KF, not KK. Okay. KF. Compound plus compound. What does that remind you of? Double replacement. Okay. So what happens with double placement? The positive ions change places. Or you can think of it as a negative ion. It's easier just to look at the positive. So the K will replace the rubidium. So you will get K2SO4. And then the rubidium places the K. And then the rubidium, I think, is 1, right? So it should be RBF. And we got to balance it. Try this. That works. Okay. So I'll show you that movie. Take a little mini break here. What time is it? Yeah, you got time. A couple minutes. Won't get through the whole video, but we'll start it. Yes, go ahead, Sophia. Yeah. Talk to you later.